Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss how to find length of a singly linked list in Java. So friends, let's suppose we are given a singly linked list having 4 nodes with data as 10, 1, 8, 11. Now in this singly linked list, head is pointing to the first node, and as you can see the last node is pointing to null. And we also know there are 4 nodes into the singly linked list. So in order to find the length of the singly linked list, below is the algorithm for it. So let's see the demonstration of this algorithm step by step. So in the first step, what we'll do, we'll create an integer variable count which will hold the actual count of the number of nodes in the singly linked list. So friends, initially the value of count will be 0. So it would look something like this. Moving ahead. So friends, now we'll define a list node by name current, and which will point to the head. So it would look something like this. That as head is pointing to this first node, now current will also point to the first node. Moving ahead. So friends, in order to find the length of this singly linked list, we need to traverse each node one by one, and we need to increment the count by 1. So friends, in order to traverse each node one by one, we will provide a while loop, and in while loop will provide a condition that current is not equal to null. So when the current is equal to null, we can come to know that list has reached its end and there are no more nodes left to be traversed. So here you can see current is pointing to this first node, therefore it's not equal to null. Therefore the condition in while block comes out to be true. So in the first step, what we'll do, we'll increment the value of count by 1. Moving ahead. So friend, as current is pointing to first node, so we have already counted this node. So now it's the time to move to its next node. So here you can see current is pointing to this first node and current's next is pointing to the second node. So in order to traverse current to its next node, what we'll do, we'll simply assign the value of current.next to current. So it would look something like this. So friends, here we simply assign the value of current next to current. So therefore now current is pointing to the second node having data as 1. Moving ahead. So now we'll again check whether current is equal to null or not. So here you can see this current is pointing to the second node having data as 1. Therefore it's not equal to null. So the condition in while block comes out to be true. In the first step, we'll simply increment the count by 1. Moving ahead. And as we have traversed this node, now it's time to move to its next node. So here you can see current is pointing to the second node and its next is pointing to this third node. So in order to make current traverse to this third node, what we'll do, we'll simply assign the value of current.next to current. So current.next is pointing to third node, therefore we'll assign this value to current. So it would look something like this. We'll now again check whether current is equal to null or not. So as current is pointing to this third node, therefore it's not equal to null. We'll again increment the count by 1. And then we'll simply move current to its next node by assigning current.next value to current. So it would look something like this. Now again current is not equal to null, therefore condition in while block comes out to be true. We'll increment the count by 1. And then we'll simply traverse current to its next node by assigning current.next value to current. So here you can see current is pointing to its last node and its next is pointing to null. and as we are assigning current dot next value to current, therefore now current will point to null. So it would look something like this. We will check whether current is equal to null or not. So here you can see now current is equal to null. Therefore condition in while block comes out to be false. And we also know that we have reached to the end of the singly linked list. So now there are no more nodes left to be traversed. So in the final step, we'll simply return the value of count, which is nothing but 4. And we also know there are 4 nodes, 1, 2, 3 and 4. So friends, let's go to Eclipse and see the working of this algorithm.